Trigonometric functions, transformations, and translations. Using the formula y equal a sine k times x minus d plus c. In this video, we are going to look at how to draw a graph that represents a trigonometric function. To do that, we are going to open up our browser, and in the address box, we are going to type www.geogebra.com, geogebra.com. Once the main menu opens up, we're going to click on Graphing Calculator. Now, here we have our basic graph, but we want to make some changes. So we're going to click on the wheel in the top right corner, and we're going to go to Settings. Okay, for the x-axis, we want the label to be x, the unit of measure to be pi. For the y-axis, we want the label to be y. Okay, now we can hold our cursor and position the graph, and we're dividing this into 5 units. So 1, 2, 3, 4, 5. We've chosen 5 because if you read the question that we will be doing and determine the period, it's 4/5. So we want to maintain the 5 units. Now, if it's not set for 5, go into Settings and go into the x-axis and go to Grid and make your distance in here 5. Okay? And that will set that up for you. Now that we've got this set up, let's come up to our input box in the top left corner, and in that box we're going to type y equals sine x. And there we have our basic sine graph. Okay, we notice that it starts at 0 to pi and then to 2 pi. So one complete pattern is from 0 to 2 pi. Alright, now if you click on it, it's going to produce dots that show you the starting point, the maximum point, the crossover point, the minimum point, and the ending point of one cycle. Okay? So from there, what we want to do is we want to make this a different color. So we're going to click on the graph, and we're going to go into color, and we can click on plus, and I'm going to make this just a pale green so that we can see it in the background. Okay? So that means now we're ready to begin. So the first thing we want to see is what happens when we change the value of A. And A represents the amplitude. The amplitude is the difference between 0, the middle point, which is represented by C, the axis of curve, and A, which is 1, which is the amplitude. So to do that, I'm going to click in the inbox, and I'm going to type y equals, and in our question, we were given 1/2 as the amplitude. So 1/2 sine x. Now we'll see that line in blue, and what we will notice is that instead of the highest point being at 1, it's now at 0.5. And when we look at the minimum point, instead of going down to -1, it went down to -0.5. So the role of the amplitude is to determine how high each top will be to the crest, and then how far down to the bottom. Okay, now again, I'm going to click on this and I'm going to change the color. I'll make this a pink color so that it sort of fades into the background. Okay, so notice over here it actually tells me the color of each graph. So the next part that I want to add is the C value, which is determining where the axis of curve goes. So now I'm going to say y equals, and I want my amplitude, I want my graph, and my amplitude, or my phase shift in this question is 1 unit down. So I'm going to add -1. So now you'll see the new graph, and you'll notice that instead of the midpoint being at 0, it's now shifted down to -1. The graph still follows the same pattern as the light pink, but it's shifted down. So that's the function of the -1. Okay, let's just change this to a paler color. Oops, sorry. Color. Let's make this a blue. Okay? So again, now this shows us our different colors. So the next thing we want to see is what happens when we change the period length. And the period length is represented by K. Now, the formula for this is 2 pi divided by the period. And we are told in the question that the period is 5 divided by 2. Now, if we do some math, we will notice that K is 2 pi divided by the period, which gives us 2 pi divided by 5 over 2. And we know to divide, you multiply by the reciprocal, which means you flip it. So it becomes 2 pi times 2 divided by 5. And that gives us 4 pi over 5. So now in our graph, we're going to use that value. So what we're going to do now is our next input is say y equals 1 divided by 2 sine bracket. Now we're going to put the K value. And the K value we said was 4 pi divided by 5. Okay? And now we want to, we need to put our x in there, of course, and then our -1. So what happened here in the orange one is that where before we had one pattern stretching out from 0 to 2 pi, now we have one pattern occurring, and if you count your little subticks here, it's 1, 2, 3, 4, 1, 2, 3, 4. So out of 5 possible subticks, it took 4. So we have 4 out of 5. But it's still using our pi as our reference measure. So what this does, the 4 pi over 5, it actually changes the length of one cycle. Not the height, because that was your amplitude, but the length. And that's what the orange is showing us. Okay, so now let's set a color for that. And we're going to make this purple. Okay, so the last one we're going to add is the phase shift. All right, now the thing to know that the phase shift to the right means that when we enter the phase shift value into the equation, we have to use the opposite direction. And that is because when we're solving it, if we say x minus 3 over 2 equals a value, then that becomes x equals 3 over 2, which becomes positive. So we always have to write it with its opposite value. So y equals 1 divided by 2 sine 4 pi 4 pi divided by 5. No, that's not what I want. We have this 4 pi divided by 5. Now in here we need another bracket, and we're going to say x minus 3 divided by 2. And we're not going to say x equal, we're going to say x minus. Okay? Then you're going to come outside both closing brackets minus 1. All right, and that gives us our final graph. And that's shown here in, let's change this color. Let's make it really stand out. So we will use a bright color here. All right, so what actually happened is that the phase shift was to the left. Okay, so instead of starting here at 0, it shifted to the left. Oops. Okay, and now the pattern starts there. So by putting these steps in sequence, you can see what each one happens, or what happens during each step. Okay, so our starting point was here, but now it shifted over to here. Okay, and that's how you apply trigonometric function shifts, horizontal and vertical, transformations and translations. Transformations means that we change the size either horizontally or vertically, and translation means we move it left, right, or top, bottom, depending on the direction. Okay, and now we have our final answer given what was provided in the question.